Hello and welcome to another video. In this video we're going to be continuing on with the Typescript line 75, and we're going to be doing longest palindromic substring. So in this string I'll briefly describe the problem and the solution. So you have a string and we're trying to return the longest palindromic substring. So in this first one it's actually BAB or it's ABA of length 3. And in the second string, it is BB. So let's figure out how we could actually do this, right? So let's say we have BABAD. How would we do this? And there's a few ways you could do this, but the easiest way to get the longest palindromic substring that is a contiguous sequence of the actual string is we want to build up our strings from the start, and we wanted to see like how big can we make it from every single index. So a palindrome can either be odd or even. Right? Those are our two choices. So for odd palindromes, they're actually going to start at one letter, and we're going to be expanding. And then an even palindrome is going to start at two letters that are the same. So essentially what we're going to do is we're going to loop through here, and we're going to try to get every single odd palindrome. So let's just have some result. And the way we're going to do this is we're going to check, like, okay, for this B letter, we'll just start here, and then we'll just keep trying to expand out. And as long as the left and the right, are in bounds and they're the same, we can keep expanding out. So for example, for this B, we're going to try to expand outwards, and this is out of bounds, so this is only just B. So for now, we're going to say our result is B, because that's the longest palindrome we had there. Now for A, we're going to try to expand outwards, so we're going to go here and here, and they are in the list, and they are equal to each other, so we can keep trying to expand. So if we try to expand one more time, this is not work, because this is out of bounds. So now our longest palindrome is actually BAB, so we are going to delete this. And now we are going to try to go to the next letter. Whoops. Okay, so we're going to go to this letter here. Actually, sorry, this letter here. Okay, and we're going to try to expand outwards. We can. Okay, but that's the same length as the BAB, so we don't necessarily need to replace it. Now let's try to expand again. And so this B and this D are different, so this is not a palindrome, so now we're done with that letter. Now we are going to A, and we try to expand outward, but we can't because these letters are different. And now we go to D and we try to expand outward, and we can't because this is out of bounds. So that's essentially how you do it. You just take every letter and you keep trying to expand all the way out from that. And that would give you every odd palindrome. But now we need every even palindrome. So now for all the even palindromes, we can just start at like a letter. We can just start at every letter after the first letter. And we can just compare it to the letter before it, right? So let's say we're at A. We'll compare A to B. And are those equal? Well, no, they're not. So that's not a palindrome already. So we can move on. Now we can go to this letter, and we'll go over here, and we'll compare this. Are they equal? No, they're not, so we can't do this. Okay, now let's go to this letter, and let's compare it to the letter before. Are they equal? No, they're not, so that's not a palindrome either. Now finally, this last letter, we go over here, compare, and no, they're not. So now we have every even palindrome, and if letters were equal, then you would just do the same thing. You would keep expanding and expanding and expanding, and then as soon as your string is bigger than the result, we are just going to override the result, and that's how you would get every even and odd palindrome. Okay, so we want to figure out the time and space complexity really quick, just to kind of get a rough idea. So what's going to happen here is the time, we are looping through every letter, and then we are expanding. So looping through every letter is O of n, and then expanding outward, the maximum word can be your entire string, so that's also O of n. This is O of n squared time, and then space, we're going to be doing some tricks to have O1 space, which I'll get into a little bit later. Okay, so now we have enough to like start coding in Typescript, and let's get into that. So there's a few changes I made in the Typescript compiler from the other problem. So essentially I added a few things. I added a, here it is, root directory, which is essentially where our Typescript files will be. And then I also have an out directory, which is where the JavaScript files will go. And so I wanted to separate them out because, right, you don't want to have TypeScript and JavaScript files all in the same folder. So this is going to separate them out for us, which is good. And yeah, I think I added a few more things, but they're not super important. So now let's get into the actual problem. Okay, so as you can see, as always in TypeScript, because we have some like values that we're not using, we're getting some errors, which is totally fine. So the tricks we're going to be using is instead of storing a result, we're actually going to be just storing the index of the left and right part of the string, right? So let's say the result is like string 0 to 2 or something. Then we're just going to store 0 and 2, and then we will make the string after we have those two indices at the end. So we're going to get the indices, and then we're going to make the string at the end, because we don't want to have to keep making a new string. That's not good, right? You don't want to have to keep rebuilding the string. Okay. So what we're going to do is we are going to declare 2 integers. And actually, we don't even need a result. We're just going to declare 2 integers as like the left and the right index of the result. And we can easily get the length of the result that way, right? Like if we have a left and a right, then the result is just right minus left plus 1, kind of like a sliding window. Okay. So we're going to make those. So we're going to say let left and right equals, and let's just make those. So actually, you can't do this because it's JavaScript, not Python. So we're going to make left equals 0. And we are going to make right equals 0. You could do it this way, though. It's giving us an error for now just because we have unused values, but we'll fix that later. Okay. Now, we're actually going to make a helper function because we're essentially going to be repeating the exact same code for the odd and even palindromes. Roughly, it's almost the same. So we're actually going to make a helper function here. So let's do that. So we're going to make function. We're going to call it maybe like build palindrome. It's going to take 2 indices. Let's just call that a left and a right. And what it's going to do is it's going to build the longest palindrome it can. We're also going to have, so right, we do have this left and right. Okay, so now we're essentially going to have a while loop here. So we're going to say while left and right are in bounds. So left is greater than or equal to 0. And right is less than string.length or s.length. And s left equals s right. Like we want to make sure the values are equal, right, for it to be a palindrome. So while that's true, okay, so actually this left and this right are the same name, so let's actually change these names. So let's make this res left, and let's make this res right. Okay, there we go. So the length of the result string is going to be res left, or res right, sorry, minus res left. You could also store the value if you wanted to. Plus 1 is less than right minus left plus 1. So you can see these plus 1s cancels out, so we can get rid of those. So essentially, if our result string is smaller than our current string, we just want to be replacing the values, right? So let's do that. So we can say res right equals right, and res left equals left. And the nice thing is in TypeScript, so we have 2 options of like naming our variables. We can either give it a type or we can just declare them right away. And if you declare them right away and you give them a value, then we don't have to worry about like the type because it will save the type. So we can't just like all of a sudden change it to a string. We can't just do like equals like a string here. Right? So that gives you an error. So those are the 2 ways you could do it. Or you can say it's type number, but this is kind of like redundant because we already made it a number. Okay. So now we are changing our result, and now finally we have to update our stuff. So now we're going to keep expanding outward. So it's going to be left minus minus, yeah, and then right plus plus. Okay. And yeah, we don't need to return anything, so I think we do need to give it a type. We also need to give these 2 types because we didn't specify those. So this is going to be a number. This is going to be a number, and we are going to be returning void. Okay, let's see what issue we have. Right is declared, value never read. Oh yeah, so we're going to call that, so that's not a problem. And we also need to do this. Okay, so now that we have that function, we have that helper function, now all we have to do is loop through our stuff and call that function. So we can just say like for let I equals 0. Yeah, I is less than s.length. I plus plus. Now we are going to call this build palindrome thing. So for odds, we're just going to give it the same I for left and right. So if you think about it, if we have a word like A, B, C, D, we're just going to say left and right is B, and then we'll expand outward, and that way we'll have odd numbers, right? So if left and right is B, then we expand, we have odd, and so on. And for even, we're going to make them 2 different values. So we're going to say build palindrome, and the left is going to be, so for the odds, we're going to have I, and for the evens, we are going to have I and I minus 1. And now finally, we need to return here, we need to return the result, right? And so we're going to return here s.slice, and it's going to be res left is the left, and then the right is going to be res left, and the right is going to be res right plus 1, because this is exclusive, right? So if the indices were like 0 and 5, you would return, you have to do slice 0 and 6, and that would return you the string from 0 to 5, inclusive, so 0 to 5. Okay, so that's why you have to do one more on the right. Okay, okay, so let's see what issues we have here. Type string. Oh, right, so we are returning void. Okay. Oh yeah, we forgot to close this method here. So this method needs to close here. Now we have this. Now we should be good. And so remember, we learned how to test stuff, so we can actually try to test stuff. So we can say like console log, and we can do longest palindrome, and we can give it a string here. So let's just say like bad or something, right? Like our example was. And the nice thing is we installed Quokka, so we can save this, and we can just hit Quokka, and it should show us our stuff. So we do have Bab. And that's nicely about Quokka is you get real-time updates without actually having to run your code a bunch. Okay, and let's try something else. So let's try CBBD, the other example, BB perfect. And let's try a man, a plan, a canal. And so that does work as well. So you can see we're getting the right output here all the time. So our function looks good. And so we're going to save this. And then if you wanted to, you could open up a terminal here, and you can do npm run build, and that should convert everything to TypeScript, I believe. Yeah, and so we could do npm start if we wanted to also, which would run our file. And so it does print the right thing. Okay, so now let's take our code and let's copy it. And let's actually bring up the LeetCode. And let's just paste it in. And so you can see it's fine. Let's see what happens. Okay. And so it does work, and it's reasonably efficient. And yeah, so like I said earlier, the time here, oh, I forgot we're not in Python again. So the time is going to be O of n squared, because we are going through every single number, and then we are building from that. So it's a nested for loop, essentially. And the space is going to be O of 1, because we're just storing, we never actually stored a result, we just stored indices, and then finally at the very end we just give a result. So that's why it's going to be that. But yeah, I wanted to add one more thing, and so that's, I'm going to actually add this into a GitHub file, and so I will be posting the GitHub repo, which will have all of the problems and all the code and all the JavaScript code, and you can actually just run your own stuff in this LeetCode problem. And you can either run it directly, or you could compile it to JavaScript or whatever you want, right? npm start will technically just run. It'll compile your stuff. It'll turn it to JavaScript, and it will run it, as you can see here. This is what it returned. Okay, but that's going to be it for this problem. So hopefully you liked it, and if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.